Welcome to the Out There channel, live stream 36. I'll just do the usual checks and play some music, and I'll be with you in a minute. Tonight we're going to cover the science and theories involving how UFOs can move and float in our atmosphere. And some of it's going to be probably a wee bit deep and scientific, but I'll try and keep it laypersons as much as possible. Looks like it's all working okay. I'm not too sure if anyone's out there. Just say hello if you are. Remember the rules. Any trolling will get yourself kicked. Swear words. So just pause the music. So where do we begin? It's quite a difficult topic. Almost wasn't going to do it tonight because I felt so tired. My energy levels have been really bad lately. I think it's because I don't sleep very well because of my bad back. It interrupts my sleep. Yes, so I'll just put a caption up here, I guess, on the screen. See how well it goes. a wee bit bigger, isn't it? Reduce it down a bit. I'll probably be trying to draw interactive diagrams to explain stuff. From what I understand by reading various people, a lot of people are hooked up on quantum physics, Big Bang, dark matter, string theory, and simply ignore what Tesla had found. He was sort of written out of science books. So, first of all, what are the most common shapes of UFOs? And normally, the ones that are most common seen, which the shape does matter, and what I'm going to explain anyway. So we've got triangles, equilateral triangles. It's not really equilateral though, that one. Make it a bit thicker. I welcome any other theories down the side chat too, or in the comments later if you're catching it later. And we've got sphere ones. Probably could draw that three-dimensionally. Let's see. Oh, that's meant to be a separate thing. There we go. That does a pretty good job. First time I've used that one. And we got the classic dome ones. So we've got a dome, three-dimensional dome here. Let's zoom in and have a look. Now we got that one there, and that one there. And we got that triangle one here. That one looks actually good for a triangle. It's got round corners. Now we'll select that one. Oh, I forgot to move it across again. We'll get there. You really want, it's really a combination, isn't it? It's not really a dome shaped craft, it's more saucer shaped with a bit on the top. I don't know how we do that. Good question. Probably elliptical. These are the most common ones. We're not using the best of the space. Then we want to put a dome on top. So we need that one. I've got to click off that first as it changes it. I suppose we could go with that one actually. I want to put extra dome on top. That will work. It's looking quite good. There we go. I was going to change this one here too. Try the other one. See how much better it is. Yeah, it looks better. The TR3B. It's not looking too bad. So we've got the three main types here. But they also has, this one always has something in the middle and corners as well. So I should draw that in too. I'm not so good with the drawing, especially the mouse. Looking good. I should just copy and paste that one. Won't let us. It's the wrong shape. Oh, that'll do. Holy moly. So let's have 3 UFOs anyway. 3 types. Three. You could say there's actually lots more variations on this, but really they boil down to those 3 shapes. Some of them have taller bell-shaped bits in the middle, and spheres might have little bits sticking out the sides, and the triangle ones, you got V craft, which could be similar to the triangles, and could be military ones as well. 3 types generally. Well, I call them base types. Base types, 3 base types. So I'll just save that slide. Looks like we haven't got anyone join us. Not too sure why. Maybe notification hasn't been sent out. So we call it ping. Three UFO types. will maybe put out a broadcast just in case people don't get a message from Google. I'll post it on Twitter. Guess it's late at night on a Friday in America. So there we go. Posted on Twitter. I think that will do probably. So first of all, we need to do another slide. And a new slide. New. It's got the wrong size for some reason. 1280. Not wrong there. Okay, I should do it. So, where to begin? Begin. Yeah, I have bookmarked some stuff. Why is it not coming up? First of all, we need to understand the basics of science, the atom model, and then look at all the theories out there and try and connect the dots, so to speak. You've probably heard people say that our science has been corrupted, or we're stuck in this worldview of Big Bang science. Now, let's see, I need to open up this. Might be already open. Now, I was talking to my mate, who's a bit of a scientist and out-of-box thinker, and copied some stuff that he said in an email to me. It's opened up our screen. So I'll probably talk about what he said. So we'll get to that eventually. So yeah, back to the atom. Remember, it will be blurry unless you do 720p. I better just double check the sound's working again. Looks like it's all going still. So, did some Googling earlier to try and find some decent diagrams. The atom diagram isn't what an atom looks like. Now, in high school, we probably were the same. We're always brought up with this model of the atom with a center nucleus with electrons spinning around in shells at different heights around the atom. So as it says here, we'll do some reading out. The diagram of an atom is among the most familiar symbols of science there is. You even find it featured prominently in our app. I suppose, what is it, BBC or something, American. Unfortunately, it's not actually what atoms look like, and we've known that for nearly a century. So that was the base model here, with the helium, He, helium nucleus with two. They call it the planetary model. So you could just imagine that our solar system could be an atom. We may, the science fiction about how you scale down atoms into smaller and smaller particles, and it all represents planets. So Earth could be like carbon atom, and then the next one, Venus, could have been another type of atom like hydrogen, and the next one, Jupiter being a big one, could be uranium and stuff like that, and how it's all linked together into a molecule. So the solar system is essentially atoms in a molecule. So that's how they sort of sci-fi had been sort of treating it. You've probably seen the movies Fantastic Voyage, where they shrink down a submarine and inject it into someone's bloodstream to try and fix them. Nanotechnology. So how the diagram came to be. The history of the atomic model is long. We could go back as far as the ancient Greeks, but for our purposes, we can start around 1900. It was about then that Sir Joseph John Thomson discovered the electron, which is the negatively charged part of the atom. He proposed that these electrons were captured in uniform spheres of positively charged matter, and this was dubbed the plum pudding model, since electrons in the positive substance is a bit like plums in English pudding. Yeah. And then we got this New Zealand scientist, Ernest Rutherford, calls this, even the model of calling things positive and negative is like good versus evil in the Bible and all that sort of stuff, angels and demons. Everyone's sort of stuck on symmetry, I guess. But I may see if I can, if I don't forget, bring up some alternative views to that as well. So it's all a bit fuzzy, and our world view is all based on all these different ideas, and generally the majority wins, which may not be the best option, of course. New Zealand physicist Ernest Rutherford discovered that if you shoot positive particles at atoms in a form of gold foil, they don't all bounce off the way they should if was a large mass of positive pudding. Instead, some bounced off, but most passed through, suggesting that electrons are spread around a small mass of positive substance, a nucleus, if you will. He reiterated the model in 1911 to have electrons orbiting a nucleus the way that planets orbit the sun, which was dubbed the planetary model for obvious reasons. Planetary model has become the most famous symbol for the atom, even though it was refined only 2 years later by Danish physicist Niels Bohr. Problem with the planetary model is the electrons would lose energy by orbiting, causing them to collapse into the nucleus. Bohr's model solved this. Instead of orbiting willy-nilly, electrons orbited only at very specific energy levels. Electrons could jump from level to level if they absorbed or released energy, but they never drifted between levels. The Bohr model is probably the most popular in science books. You would recognize the nucleus surrounded by ever larger circles of electrons, but you suggested it's mostly wrong too. So here they are. We've got a cloud of negative charge, 2 electrons. So it's fuzzy, fuzzy how it orbits. And the nucleus was made up of positive protons and neutrons. As you know, that Einstein's E equals mc squared kind of suggests that matter accelerated becomes energy, and energy can be thus turned back into matter and light using that equation, which kind of suggests that everything is energy in some form, and we just see it as solid mass. So we'll get maybe more into that later. Gets a bit complicated. So do we need to know any more on this page? What's really going on? Stephen Dutch of University of Wisconsin, Green Bay clearly sums up the next step in the type model. By the 1920s, physicists had discovered that matter also has wave-like properties, and that it's just doesn't work at the atomic level to regard particles as tiny points with precise locations and energy. Matter is inherently fuzzy. They give up thinking of electrons as tiny planets altogether. Electrons don't really follow paths at all. Physicists discovered that they are actually quantum particles that exist in many different places at once. They still occupy individual energy levels, but instead of path each electron many places at once, location could be thought as a cloud of, that's why it's known as a cloud model. So it's not easy to say Bohr was wrong. It's a good way to simplify a very complicated concept. It actually works surprisingly well for simple atoms like hydrogen, but the electron cloud model illustrates the latest knowledge about the structure of the atom. The planetary model is pretty, but it's not real. This is not what an atom looks like. So they've got a little video there. So that's on that page. There's probably some other pictures that we can bring up. Atoms 3D, maybe. So here we get some models of atoms. that you may be more familiar with. See, they can't really represent it as a fuzzy outer. So it boils down to the next question. I think I'll get it on the next one. Here we go. We've got some more on atom here. What does an atom look like? And here we go. The big problem with answering what does the atom look like is that in order to look at something, we normally shine light on it and observe the light that bounces off. Visible light has a wavelength that is much bigger than atoms. It's impossible to make out small details of objects by probing them with waves of large size. In other words, a photon particle is a wave. The waves simply flow around the small object. Shorter wavelength light may be used. I guess that would be ultraviolet, is it? That side. Infrared would be the large end, not the shorter end. But the energy per photon increases as the wavelength shortens. As it turns out, where are we gone? As it turns out, when the light has a wavelength comparable to the size of the atom or smaller, it has enough energy to change the atom by moving the electrons around. So they're saying by observing it, you can actually change what you're looking at. Isn't that the quantum effect? We cannot say where the electrons are and how fast they are moving at the same time, and hence we cannot draw a picture with a little electron on one place sitting on a circular orbit. The fuzzy picture at the bottom of the page linked is closer to the truth, describing the properties of finding electrons depending on where you look for them. You can see science is very fuzzy. So, the nucleus containing protons and neutrons has a similar problem, but it's much, much smaller than the electron cloud, and hence the energy of a photon needed to resolve structure is much higher. Heisenberg uncertainty principle applies to neutrons and protons as well, and so a fuzzy nucleus isn't such a bad representation either, but for show in class, the clear pictures showing the details get across. The important points of the atom consists of protons, neutrons, and electrons. That the protons and neutrons are in the nucleus and the electrons are found at larger radii. Ooh, yeah. So, what color are atoms? It's great to hear such a curious 6-year-old. Rennie asks what they look like. There are at least two sides to the question. One is the shape they are, and the other is their color. It turns out that the visible light is no good for seeing the shape of atoms because of the wavelength. So we've sort of gone through that. The wavelength of visible light is about 400 nanometers to 700 nanometers. A nanometer is 1/billionth of a meter, about 1/15,000 to 1/200,000 of a human hair. Yep, we have to believe. So while individual atoms can reflect visible light because atoms are so much smaller than light, you will never be able to see any more than a fuzzy dot. In order to clearly visualize atoms, a scanning tunneling microscope is used, which is a microscope that uses electrons instead of light to see very small objects. The resolution of these microscopes is good enough so that individual atoms can be seen as bumps. Some of the most famous pictures of individual atoms is the latest IBM. Below actual images, you can take a look at some of the early responses. So here's the best they can get looking at atoms. You can see here we've got the letter I. So is that, are these individual atoms or group of atoms? It's not terribly clear. So really, they look like miniature icebergs if that's the case. Fuzzy blobs, even with electron microscope. So that must be the paper underneath here. So as for the color, atoms can have visible colors, although it's hard to see unless you have lots of them. By an object's color, people sometimes mean the color of the light that bounces off it. So is there anything else we need to add there? Not really. So what's the next one? How do scientists figure out what elements make up a given molecule? Well, elements are atoms, like carbon, hydrogen. Probably should put that in Google. What is an element? Now you've heard of the periodic table, where they've got a list of all the elements, gases, metals. And they've worked out how many electrons and neutrons and protons they have. And they know how atoms sort of bond together with other atoms based on the energy level of the electrons. And they sort of click together like Lego in sort of a way, and share the energy to become stable. So they're not actually hard screwed together, so to speak. You can break it apart, like you can break water into hydrogen and oxygen. If you put energy in and smash them apart, which is called what do you call it? What do you call it? So here you go, the periodic table showing elements. Electrolysis is what I was thinking of. It's funny how you can't think of the words when you need it. So when you're splitting water, it sort of bubbles out the gas when you put in current between a spark gap. So can we open that up even more? Probably not. I'll just zoom on that one then. So they're the elements we know about. Where's carbon? Up here. It's got normally numbers telling you the protons and electrons and stuff inside the boxes. And they've been grouped, obviously. So we go back to how they figure out what elements make up a given molecule. So since we can't actually see, say, what's in a piece of material from a UFO, say, a piece of metal or something, there's certain tests they have to do to try and guess what, well, not guess, well, educated guess, or what it is made of through breaking up into smaller bits. And the way they do that is these methods here. Flame tests are used to detect the presence of certain elements, primarily metal ions. Mass spectrometer mass spectrometer helps identify the number and type of chemicals present in a sample. And you've probably heard that one the most on UFO shows, where they get like an alien implant and stick it under that process. X-ray crystal how do you say that one? Crystallography, used for identifying the atomic and molecular structure of a crystal. And the other one that I was talking about, electrolysis, can be used to break certain molecules into compounds which can be analyzed. Electrolysis, there you go. If I don't think about it, I can say it. This is what happens when you don't sleep very well. I've actually installed a speaking thing. Let's see if it'll work actually. If I highlight that and right click and say the plugin, read aloud, see if it works. It's very slow. Did I choose the right one? I think I did. I know what I've done. I unmuted it. So let's try that again.
Electrolysis can be used to break certain molecules into compounds, which can then be analyzed.
There you go. A wee bit better than Stephen Hawkins. Not sure if it can read a whole paragraph, but we'll try it. So it'll come in handy when I can't say the words. I don't think it's going to work. I think it's got a wee bit buggy, but it's good for reading a sentence. See what happens.
Here are some tests that I am aware of that can be used to discover what elements there are in a compound. Flame tests, used to detect the presence of certain elements.
Yeah, see? Maybe it's got a limited buffer or something. But it's going to be quite handy, I guess. Let's try that one.
Mass spectrometer helps identify the amount and type of chemicals present in a sample.
So that sort of worked. And so I googled up this mass spectrometer, and you can see this is the simple version, and it's quite in-depth and involved, and it's the basic principle. I wonder if it will read it out for us. Save me having to read it. Test. I test it out.
How a mass spectrometer works. The basic principle: if something is moving and you subject it to a sideways force, instead of moving in a straight line, it will move in a curve, deflected out of its.
Yeah, it's very limited, the size of the sentence. Bit of a shame, but it was reading it quite good. So what they're saying here, suppose you had a cannonball traveling past you and you wanted to deflect it. I'll just mute that again. So I hear myself talking, it sort of interrupts what I'm saying. So I don't think anyone's joined us yet, but that's all right. They can watch it later. So whereabouts were we? Cannonball traveling past you and you want to deflect it as it went by you. All you've got is a jet of water from a hose pipe that you can squirt at it. Frankly, it's not going to make a lot of difference because the cannonball is so heavy it will hardly be deflected at all. But suppose instead you tried to deflect a table tennis ball traveling at the same speed as the cannonball using the same jet water. Because this ball is so light, you will get a huge deflection. The amount of deflection you get for a given sideways force depends on the mass of the ball. If you knew the speed of the ball and the size of the force, you can calculate the mass of the ball. If you knew what sort of curved path it was deflected through, the less deflection, the heavier the ball. So they can work out how heavy, well, a molecule is passing, I guess, and then break it up into its subparts even further. So obviously, iron is going to be heavier than carbon or hydrogen as it gets deflected. So the way they do that is stage one, they say here, ionization. The atom or molecule is ionized by knocking one or more electrons off to give a positive ion. This is true even for things which you would normally expect to form negative ions, chlorine, for example, or never form ions at all. Argon, for example, most mass spectrometers work with positive ions. So does that mean it's not foolproof? And then you got acceleration. The ions are accelerated, so they all have the same kinetic energy, and then deflected. The ions are then deflected by a magnetic field according to their masses. The lighter they are, the more they are deflected. The amount of deflection also depends on the number of positive charges on the ion. In other words, on how many electrons were knocked off in the first stage. The more ion is charged and the more it gets deflected. So here's a little diagram. Acceleration, deflection. vacuum pump, chart recorder, amplifier. So essentially it's to do with the deflection and a speed, or how heavy it is. And then you get a chart like this: abundance versus what is it, bottom line? Relative abundance or relative intensity, which means the same thing. And you see in the diagram, the commonest ion has a mass charge ratio, so M/Z, mass charge. That means that molybdenum consists of 7 different isotopes. Assuming that the ions all have a charge of +1, that means the masses of the 7 isotopes on the carbon-12 scale are 92, 94, blah, blah, blah. So it's starting to get a wee bit more complicated understanding the chart. So it's not looking at individual atoms in this case, so talking about it being isotopes. So to understand the chart, I'll try to figure it, find a page on that. Why is it not coming up? Did not load. Reload it, maybe. There we go for time. So I've been talking about this basics. Why is it not loading that page? Come up. How to read a school mass spectrum. Finally. Okay. And you see, someone's written a paper. That looks of it. And he's done it hand drawn, hasn't done computer charts. And I didn't find it very easy at all to understand. You can see there's a little blurb. Mass spectrometry. So here, I've identified the molecular ion, and here he's got water. So it shows up on the chart like that. So it's not just split into hydrogen and oxygen. So I guess what you can say is, if it's a combination of different compounds, substances, you should get a bar for oxygen, one for salt, maybe, and so on. Carbon chains. Identify major fragmentation clusters. And so that's on to another substance, obviously. And then we'll do some calculations. Determine the mass for each major peak. I guess that is mass, isn't it? So we'll look, or maybe it's just major peak. Oh, yep, mass difference, triangle. Now, I won't go into too much details on this because it's quite complicated. This is a simple example, so I'll leave it up to the experts. So you can see why people say you've got to get it tested, like apart from a UFO crash, you've got to get it tested by multiple people, because interpreting what's coming off is key. And here we got a chart where he's talking about loss of iodine. I guess the peaks form certain signatures, you know, like the water one was laid down here. And then they can work out what it looks like. Don't ask me how. I haven't really got my head around it. This is meant to be the layperson's version. But I wasn't going to go too much into that anyway. Just going to bring it up because it was quite interesting, related to how we can work out what's in a piece of substance. We got this other one here, which is similar. How do we know what stars like the sun are made of? So obviously we can't get a piece of the sun and stick it through the previous testing, but there's another way to work out what's in the sun's surface by what light is filtered. So I'll just have a read of this here. Was it from BBC? Excuse me. This was 2 years ago. Every day for billions of years, the sun has risen over Earth's horizon. It may be 100 million kilometers away, but our star shines so brightly in the sky that we cannot look at it with our own eyes, lest we damage them. At surface, the sun is 5,500 degrees Celsius, hot enough to mount any landing probe in oblivion before it even got close. Now, we looked at a couple of streams back, I think it was, on the melting points of metals, and the highest one we had, I think, was 4,400 degrees Celsius. So this is another 1,100 above the highest one we've got on Earth that will melt. So, in other words, the sun is literally too hot to handle, but it doesn't mean we cannot study it. In fact, there are several ingenious techniques through which we have begun to unravel the secrets of the stars dotted throughout the night sky, as well as one in our own backyard. How then is it possible? So we begin with light itself. We might not be able to, let's see. May not be able to look at, let's see, whereabouts were we? As you know, white light is actually made up of all the colors of the rainbow, and we can see those colors from deep red through to violet if we split the light with a prism. Way back in 1802, an English scientist named William Hyde Wollaston did this with the sun's light and noticed something unexpected: dark lines in the spectrum. A few years later, the German optician Joseph von Fraunhofer built a special instrument called a spectrometer to disperse the light better. He saw even more of these dark lines. Scientists soon realized the dark lines showed where colors were missing from the spectrum. They were missing because elements in and around the sun were absorbing those specific wavelengths of light. The dark lines therefore indicated indicated the presence of certain elements such as hydrogen, sodium, and calcium. It's a remarkably clever, beautiful, and simple discovery that's more or less instantly taught us about some key elements found in the nearest star. So here's a picture of the black lines that they see when they look out into space at various stars or whatever. So what's that one of? Doesn't quite say what it's a picture of anyway. So we're sort of getting the basis of some science anyway. Then we can start looking at the other stuff that has come out since. And I'll just bring up my site. Here we go. Come on. Here we go. We'll see how slow it is. So that's our current live session here, because I need to make reference to some other documentaries I made, which will talk about how UFOs could hover, and you should watch them basically. So, where did we get to? The sun. So here's a good one also talking about this light spectrum. So the continuous spectrum should look like that from a bright white light source. But they found placing hydrogen or helium or other elements in the way, the atoms would absorb certain wavelengths of light and leave the black lines. And here's an example here. I'm not too sure, but if you have a look at this one here, you can see all the colors of the rainbow being transmitted. And when it intersects with this, was it helium, it loses one band of color there. And then the detector shows it on the chart with the band missing, and the mission one shows it. So they got opposites. The mission one just shows the bits missing. So it sort of shows it a bit better what's going on there. You see they're going to a bit of depth on that one. I'm not going to spend too much time on it. But that's quite fascinating, really, though. I'm not sure if we did that one experiment in school. It's a long time ago now, since I was in high school, 30 years ago. So let's move on to the next topic. Now, you've heard of general relativity. and Einstein's theory of space-time. So first of all, we need to know what space-time actually means and how it relates to gravity. So I'll do a search on that. Oh, I wish it was down the bottom. Odd, no one's joined us. I suppose they're still at work. Yeah, it should be evening. So maybe they're going to bed. Space-time. Space-time, the concepts of time and three-dimensional space regarded as fused into a four-dimensional continuum. So they say it's a mathematical model here that fuses three-dimensional space and time. Probably should say what is time and gravity, maybe. It is here that Einstein connected the dots to suggest that gravity is the warping of space and time. Gravity is the curvature of the universe caused by massive bodies, which determines the path that objects travel. In Einstein's view of the world, gravity is the curvature of space-time. Blah, blah, blah. It's not really a good explanation here. But it's saying like a metal ball placed on a mattress makes a dent in it, and the curvature is what we feel is gravity, and it's all around us. That's Einstein's theory. Now I'm saying it's not going to be correct, because I don't think, because I've talked about space-time is not correct, because they use those atomic clocks and they put one at sea level and one 4,000 up a mountain, and it loses time, saying that proves Einstein's space-time correct. But I say that's got other stuff that they've sort of forgotten, like we're inside the Earth's magnetic flux field and it changes with height. But also there is something that Einstein said, which I'll cover, which will connect into how he says that you can levitate things. So what you could say is, what is gravity, maybe? What is gravity? The thing is, no one knows what gravity is. It's all guesswork. Force that attracts a body towards the center of Earth or towards other physical body having mass. Well, all atoms are attracted to each other, clearly, which is what they call gravity. So the more big the body is, the more gravity pull it has. That's why the gravity is less on the moon, because it's a smaller sphere of atoms. And likewise for Mars and other planets. I suppose on Jupiter and those other big planets, the gravity is going to be even larger, and it'll be like you got lead boots on or something. So I was hoping to find a really good example. General relativity. You hear all these buzzwords on TV all the time. Simplified explanation. Is there such a thing? Is that the same one? Theory was published by Albert Einstein. Central idea of general relativity is space and time are two aspects of space-time. Space-time is curved when there is gravity, matter, energy, and momentum. The link between these forces are shown in Einstein's field equations. So that's another thing, is because you can prove it in maths doesn't mean it has to be reality. There's plenty of examples where maths is used to calculate things and it doesn't work up off planet Earth, say, like gravity, working out how a cannon shot is going to land. It's going to be different in outer space. And electronics, there's a lot of equations as well that work for some instances, but not other things. So Einstein and Nikola Tesla are quite good friends. And neither of them, I think, were 100% right, but together, both their ideas were very connective. They sort of they explained the same things, but with different terminology, I think. See, Tesla never got to see the atomic bomb to go off, so he didn't see that Einstein's equation that E equals mc squared was reality. And if he had seen that, he may have changed some of his ideas and worked more closely with Einstein again, because they sort of parted their ways a bit when Einstein decided to do quantum physics rather than Tesla's idea of what he called the ether. But it doesn't mean both were wrong or both were 100% right. So in the diagram that I had here, as I said, it's going to get complicated. Our UFOs hover. We've got three base types. And the shape of the craft are key to how they would possibly hover and float due to fields. So in Einstein's, let's see the type. Einstein is smaller. Smaller again, probably. Gravity is what Phil. What's it done over there? Damn it, what's happened? Looks like it's gone up a line. our fill is curved space. That's how you spell that. Now, Tesla's view is different. He didn't believe in the space-time business. And Tesla, unlike other scientists, Einstein was a mathematician. And because you can prove something in maths doesn't mean it's in real life, doesn't mean it's reality. Tesla was an experimenter, and he got noticed things, and then he soon narrowed down on those strange things he saw to figure out how to duplicate it, like a real scientist, and duplicate it so many times, then how to reproduce it and what causes it, sort of thing. So Tesla view of gravity. He says gravity is a flux as atoms absorb energy. To keep them spinning. Yeah, that key's not working. And so as we know, atoms are not like stationary things. They've got electrons orbiting. So we go back to the look at the model of the atom. This one again. That's what we were taught in school, but it's actually, now they think it's more like this, with a fuzzy cloud of electrons moving in all sorts of strange places and a nucleus. So basically, if we draw an atom, that's on the right one. So we've got an atom, and on the outside, it's got electrons orbiting and strange cloud, as they're saying, but it's also absorbing energy all the time to maintain its structure. So we got oops. So it's getting this mystery energy. So, so the energy is being absorbed all the time into the atoms. Now, because the energy flows like you could imagine it, that's like a river, that it's going to sort of like suck you in like a stream, and that's like gravity. Well, Einstein was thinking curved space, where you got the atom, but that it's curved. Probably should have draw a picture of that one too, but I need to draw another arrow. So we've got energy coming in all around it. I kind of like Tesla's idea. Now, apparently he did a experiment where he levitated a metal rod, a cigar-shaped rod, which is quite interesting. And that's probably one thing I missed off the chart as a rod. So it's really, could it be 4 base types? Probably got that wrong. So really I should have a rod there as well. A rod is really circular too, but let's draw a rod. Forgot about rods. How do we draw a rod? Have we got one for that? Got a cylinder, that might do it. So we got a rod. It's wrong direction. That's it. That's it almost. Why is it not moving? So really that should be direction 4. Thought I had forgotten one. And then you have variations on those standard 4. Arrays doesn't work the way we want it to. That's right. 4. Size. Probably have to fill that bit in. We're stuffing it up. Now I'll do the thing. Now we've lost the black. We'll just do a different color. 4. But I'll just resave that. I haven't on that one. How'd that get there? I don't remember drawing that one. That was meant to be an arrow, wasn't it? Now we've lost the black. I'll just copy it from one of these. Didn't work. Let's see black on the line. Yeah, that's it. Doesn't look black. Where's black? Primary. More. Is that black? Why is it not on the main chart? That's crazy. Doesn't make sense. Now we lost the arrow. Oh, it doesn't really matter, I guess. So once we probably should redraw that anyway. Make a new chart. Yeah, it's not the right size. Getting slower now. 720. So let's try atom again. So Einstein was, was that big? Well, that doesn't matter, I guess. Einstein was talking about curved space, so we draw a cross section. So it's saying that it curves space all around, and that's like water running down a sink. It creates a pull downwards. It's not a very good arrow, is it? Terrible arrow. But Tesla, he talked about an energy level called the ether, which you could imagine it like a fourth level to our three-dimensional view of the world. And this fourth level energy is everywhere. Well, Einstein's theory of curved space and Big Bang theory, they talk about dark matter, having pockets of dark matter which is most of the matter in the universe is dark that we can't see it. So they're trying to make up theories to plug holes in their models. But Tesla, this one's a lot more simpler understanding. So the atom, and that simply absorbs from the ether, which I don't know if I can draw. What can we use to draw that? What do we got? Might be a good one. It's got a mobile phone there, both up. Suppose we could do that array. I didn't click off it, did I? Keep doing that. We lost the circle. Okay. Got to click off it. There we go. Why is it not working? It's very slow. Okay, so the ether is really all around. And 0 point energy, they say, comes from this ether in the form of what Tesla called radiant energy. And of course, over this model here of the Einstein theory and space-time, they've got dark matter and they've got dark energy. It's, to me, it's sort of like the same thing. About the same thing, but they don't see it. Big still. In the dark matter, dark energy. Yeah. We've got the ether, and we've got radiant energy. I'll do. So to me, the ether over this model here of Tesla's is really what they're calling dark matter. It's all around us, and the dark energy we can't see, but Tesla says it's a electrical energy that doesn't use electrons. So it comes, and he was using high voltage to put a spark in the air, which would knock out the radiant energy in this layer in the universe or planet or whatever you want to call it. So the radiant energy is absorbed into the atom. So we got the ether, which is like a fourth dimension, and radiant energy is absorbed evenly. And of course, what happens is if you got like the mass of the planet Earth of all these different atoms, all of these are absorbing energy all around. And it doesn't need curved space. It's just there. So what Tesla was trying to do with his unlimited energy was somehow to release this radiant energy from this ether field and then convert it back into conventional power that we use called AC and store it as DC energy in batteries and capacitors. So these, as it draws in the energy, it creates what we call flux. Sounds like flux capacitor. Back to the show. So this is what they call flux. Just like you've got magnetic flux around the planet Earth, it creates a field around the Earth. This is actually going in the opposite direction. It's absorbed into all atoms. So once we know what gravity is, we now have to figure out a way to block the radiant energy going to the atom on a particular site. So let's go back to our diagrams of the UFOs. This is how I'm sort of wrapping my head around it. You see, it's just a theory. We just can't prove it at this stage. And to do this, obviously, it's going to require a lot of voltage, high voltage to be able to do it. Now, there has been some hints. Now, Tesla, I'll see if I can draw it. I think there was one of a spacecraft here. That one, wasn't it? So we get that one. Now, he had a drawing that he showed to, I think it was a nephew. So just rotate that sucker. There's a rotate angle. So he had a diagram like this of craft flying around. With passengers, windows going along the middle. So like a cigar, very cigar UFO-y. Now I've covered it on an episode, I'll bring it up in a minute. So it's a cigar shape, which is really basically a variation on the cylinder, which is quite interesting why he would choose that shape. And at the back of it, he's got a look at antenna that he's transmitting. I don't know if I've got a little satellite dish picture, have I? Well, we could probably use that one here, I suppose. Try that. So what he was doing, he was going to create his special tower that used what he called a spark gap, and would release this radiant energy into the atmosphere from the ether, and the craft would have a similar thing on it. So why is it not working? Maybe a smaller thing, or even a ship or a car. So it would have like free power, wireless power. And what's unique about the radiant energy he found, that it could pass through steel plate and glass, 3 to 5 inches thick, and still hit him in the chest and almost knock him over. And he said it stung. So you'd be transmitting this power through the atmosphere. So to get anti-gravity work, he first had to get his wireless power working, which they stopped him doing. I forgot to click off it again. That was meant to be a lightning spike. Just wanted to do it like an angled cone. There we go. That'll do. And click off it. Could always click off it. Now we need that lightning spike. As you know, Tesla had on his experiments, he was playing around with spheres and half domes. You know, the Tesla ball was actually a sphere at the top of the lightning tower. Yeah, how do we get it bigger? What's happened? I've lost my drag handles. Let's move. What's that one do? Oh, this is annoying. Oh, here we go. So we got this wireless power. Oh, I think it's just going too slow. Maybe I got too many pictures open now. I want to get it bigger. Oh, that's too big now. Too fat on me. There we go, that will do. So when it goes too slow, the editor is a bit harder to work with it. So that was his idea that he showed, I think it was a nephew, that there would be flying platforms as well as these cigar-shaped passenger type planes. They were powered by this high energy that he was transmitting. Unfortunately, he got closed down by the basically knock down his tower. I hear they're going to sort of rebuild it again by the sounds of it, from diagrams I have found out. There was a show called the Tesla Files. You may have seen it on TV. They managed to get into that museum where they had some of his paperwork locked up, and they managed to get some snapshots on camera of it. And Tesla had all these equations and also all the size of each of the building blocks to build the tower to his specifications. So they got sort of like a blueprint, because normally in the patent office you find Tesla's patents, but they're like block diagrams. They don't actually give you any specific details how to build this particular piece of equipment. So it sort of protects the idea, general block idea. So back to another diagram. Progressing on. But I will see if I can find that documentary on Tesla I did, because I really need to watch it. Now I'll go into all this sort of stuff halfway through the episode. Most of it's introduction stuff about him. There's another researcher as well called Townsend Brown that also stumbled across the similar stuff that Tesla was working on. And I did a documentary on that to try and explain it. So it'll be down here somewhere, the Tesla one. Terribly slow. I'll get past it. I know, still coming up. It's amazing how the episodes stack up. It's been really slow. Oh yeah, need to mention him too. I'll get to it in a minute. Should have been more than that. What's happened? Was I get screwed up? I think should be a lot more after that too. think I saw it here. Where was it? Tesla. So this one here. In fact, I might even have a picture of his UFO that was meant to have been drawn by his nephew, but the original was destroyed or something. So I should have already given it a title there. Slow. This one. Okay. So if I open that one up, let's see if we can find it. I'll mute it. It's like a 49-minute episode, like what you see on TV. Look how slow that is. Go on, Google. Is Google having a bad day today? Seem to have this trouble all the time. So this is this tower anyway. That was basically you're going to have like glass around the top, which is not like a normal Tesla coil that he was designing. And no one knew why it needed glass to be on the dome. But essentially it was to do with amplifying the radiant energy from the ether field and transmitting it into the air. And of course it travelled faster than the speed of light, I think he did, and passed through Earth and go through the other side. It didn't have to bounce off the atmosphere. Experimenting with power from the atmosphere as well, and also power from the ground itself. So yeah. So if I skim through, where's my it's best to watch it anyway, but make it bigger. My computer is terribly slow, as you can see. And this ain't even on 720, so even that's going to be blurry. It needs to be HD down there, I think, on the cog. I'll just try and find the bit where I'm talking about levitation. I also talk about other people that have stumbled across Tesla's ideas and got a machine that was using his radiant energy to power up a whole bank of lights and drive an electric motor, all from a car battery, I think it was. And it would run for hours, longer than what was supposed to be able to be supplied from the battery. So I talk about all that in the episode. But I think it's going to be very hard to find that picture of a UFO, this cigar UFO. Probably missed it already. I also talk about the device that he patented. This is, like I said, it doesn't tell you how to build it and what materials it's made of. But this was his spark gap. And he had rods that go around the centerpiece, which absorbed and tapped off the energy, which they then could use. It's like in physics, they have this idea of symmetry particles. And we have electricity that's has another symmetry particle to electricity. So it doesn't have, so it's not electron flow. This radiant energy is another form of electricity that it doesn't revolve electrons. So maybe it's a, what do you call it, a not a proton, position or something like that, or some other name that would give it opposite to electron. But yeah, I can't, looks like I won't be able to find it. It's too slow, you see, as well. But they might be able to find it on Google. Might be quicker. It's best to watch the documentary anyway. You'll find it interesting. It's probably a wee bit. I've tried to keep it layperson. Tried not to get it too technical, but that's science for you. You really have to get your head into it and think outside the box. Don't accept that everyone says space-time is correct, because there might be other ways to look at their conclusions, like why light is why gravity lensing works, gravitational lensing works. There's other explanations why that works, you see, and why that, again, back to the atomic clock idea about the flux affecting the oscillations, and even atomic decay when it's further up in the atmosphere to outer space, because it has to impact on the atom level, you see. And it's nothing to do with space-time. And that's why time travel, I think, is not reality. But traveling long distance in space, if you can figure out how to use this fourth dimension layer of energy, if you can sort of merge into that energy level, technically you could move anywhere in the universe pretty much instantly and then pop back out. Maybe that's how UFOs travel long distances. The theory that I had also was another one, which probably won't show up, was how aliens travel space, and I cover how some idea is that it uses the suns. Each sun in the solar system has a very dense core of energy, which connects into this ether energy layer, which in effect is like a wormhole. So once you can enter inside a sun, you can now enter into this fourth dimension layer of energy, and then you can go to any other sun in the universe, doesn't matter where it is, and then pop out of the other sun. But the key is, can you create a field around a spacecraft that protects you from all the energy of the sun to get into that bent space? Because space can be bent still. Einstein and Tesla are not really at odds with each other. Their ideas sort of complement each other. You just got to look at it differently, and that's how I sort of figured it out anyway. And to me, it's starting to make sense about how it absorbs the energy to keep the atom spinning. Now, it's hard to believe that our atoms are not actually connected to each other. They're all sort of attracted to each other like magnets in our body, and that's why you can bite your finger off, because you can break that electrical pull or electromagnetic pull of the electrons in the atoms apart. And then Einstein showed that if you can smash the nucleus of enough atoms all at the same time, that you can cause a chain reaction where particles from the other atom collide with the next atom and so on, and smashing those nucleus apart of the atoms releases a lot of energy. But I'll go more into detail how that sort of plays into it all. So I see we got a couple of people watching now. Who's out there? Anyone want to chat on the side? So what I sort of lost track now. I was talking about so many ideas to cover. You see. So I was talking about. I lost my way now. All these ideas flashing in your head. Tesla. What was it? Oh, I was looking at a spaceship. See if we'll find it. Said I'm a wee bit tired. I haven't been sleeping very well. Don't know if I can find the image or not. Why is it not working? Let's bring up Tesla car. What are we going to use for keywords then? Nicola. We're going to find it too easy, are we? I've got Nikola Tesla showing up now. It's none of those ones, it's other people's ideas, right? Need to find the original drawing that he did. I'm not seeing it. I know it's in my episode anyway. So, looks like I can't find it. Oh, it doesn't matter. And moving on anyway. The other person that I did a documentary on, which also was using high voltage, he found that charging high voltage capacitors, what's this guy here, Townsend Brown, that each plate in the capacitor actually lost weight. Again, this boils down to the idea that I was talking about, that if you can somehow block one side of the absorption of this radiant energy, then you ain't going to get the gravity underneath it, and so it will make it lighter because it's not pulling down. So that's what Townsend Brown was working on. So the idea would be to somehow reduce the weight of a craft so it's like a balloon in the atmosphere, and then you can use like very small motors or high concentrated motors like ion engines to push this object around the sky very, very fast. And because the field around the craft has reduced the absorption, even in the people inside the craft. If you've reduced the absorption of the radiant energy into the atoms of the body of the people, then they're not going to feel the same gravity as what you would outside the craft. So that means that they're not going to be affected by inertia. It's a bit hard to explain it, but it sort of all makes sense. Copy link. So you need to watch this one too on Townsend Brown. There's all sort of links in. I'll just do that. Not too on the side too well. So there is some research papers because a lot of people are researching this. A lot of the stuff that sort of come off Townsend Brown's research was these iron lifters. I'll open up that one. I'm not sure why YouTube is so slow though. So he mucked around with these saucer type designs as well. As you can see here, some old black and whites. Again, it's best to watch the episode. But he got these lifted up. And he also did it inside a vacuum. Now, iron lifters don't work in a vacuum. But he definitely did experiments with vacuum tubes, and you could see it was actually. So he used umbrellas over top of umbrellas, which is really UFO shape. See here, UFO shape. But he's using high voltages, which then cause a lift. But a lot of people said that won't work without an atmosphere. But I'm not too sure because I'm talking about the charges you see here on that. Because I found on the research papers some interesting stuff. So here you go, you got your typical saucer where he found charging it could move it forward, reverse, up, down. And he also spun it as well to keep it steady. Unfortunately, no one took his research very seriously after a while. It's not loading fast enough. But yeah, you have to watch it. They're two you have to watch to really understand gravity. So basically, what Townsend Brown noticed was X-ray machine would almost self-destruct. The capacitors, as it was charging up, would rattle and shake and want to try and break away from the machine. And he found that they were actually losing weight when they were charging, which should be impossible, right? So he wanted to look into why that was losing weight. And it's because it's generating a field around the metal, and it's affecting the absorption of this radiant energy that Tesla says exists, which is really just dark energy. There's no name for it. So let's draw a UFO. Another thing before I move on to that is a guy called, what's his name? What's that saying there? Go away. Whereabouts is it? Another documentary I did. Oh, here we go. Viktor Schauberger and the ghost rockets. Now, there was a period just after World War II where ghost rockets was mostly seen. A lot of it thought it was German research. So ghost rockets. And you can see here on this episode the same shape that Tesla was drawn for his spaceships to fly around people around the city. But we can't find it. This one's only 14 minutes long though. This guy was very clever. He managed to get heavy logs to walk up, to go up hillsides on a gradient, but like the Romans used to do with their water. But he found that certain steps and the vortex that's caused as it flows down the step would actually lift the tree stumps, and they wouldn't get stuck, and they would simply travel down. So he moved heavy objects with the least water possible, and his idea was using these vortices of energy. Again, this boils down to how to create a field around a UFO. So this links in also into blocking this radiant energy. So if you can create a field of difference around objects, it's going to float. And in this case, in this way, his rockets generated a vortex in front of him like a tornado, and it simply got sort of sucked into the energy in front of it. So it would be lifted along in the water or through the air. And I think what happened is after he died, someone got hold of his research notes and carried on researching and building the devices, because after the World War, a lot of these ghost rockets were sighted. So I'll talk about that in this episode anyway. And when you see one of his designs for a submarine, it looks very much like a ghost rocket. So I think the connection was there. We can't find. So all these ideas are sort of all connected. It's talking about energy difference. And I was talking to my mate on email who's a bit of a scientist, and this is what he said. His ideas might be slightly different than mine, but we sort of have the roughly the same idea. So I asked him, how would you draw a flying saucer with this energy difference? And he said, put a saucer or bowl upside down in the sink and swirl brush above, and it will lift. So he's talking about Viktor Schauberger. Think about multi-phase motors and how a field is made to rotate, and you have the makings of such a field. And the bit that excludes us is making it strong enough to lift the object that is currently beyond our ability. But I think if you got enough power or high voltage, that you probably can create this field that he's talking about. We have only achieved shallow versions that affect the air enough to create lift, electrostatic lifters, but we need 1,000 times stronger to lift in a vacuum or create low inertia effect. The problem in physics is officially electricity is caused by electrons, fundamental particles from creation theory belief. Until they understand that it is a multi-scale strain that will fail, they will fail to get there. So he's saying the current understanding now science is stuck on this electron being the only particle of electricity. And as I was saying that we're talking about Tesla's radiant energy, he said it is another form of electricity that doesn't use electrons. But he also said here on UFO sightings, which kind of suggests that it's using a field, that you get major radio interference affecting car electronics when a UFO approaches, sometimes even affecting other aircraft, especially the modern electronics. You've heard about fighter jets in Iran losing control and stuff. If you have the technology to generate usable energy at will by destruction of matter into channeled energy, so he's talking about probably fusion power, maybe. Now Tesla was trying to get wireless power, so you didn't have to have onboard batteries or some sort of way of generating it. You simply could just tap it straight into from the atmosphere. Then you should be able to build one. Meeting of the fields will let energy out. If you are bending a field all the way around your craft, you may become invisible except for infrared. So he's saying this could be explained why if you create the field around, which then blocks gravity, the gravity, which is flux, that the craft will become invisible, which makes a lot of sense because you hear how UFOs come out of a flash of light. I suppose it could be that they're slowing down, they're reducing the field, and they're not going super fast. I suppose there's no theory on how fast you can go. Recently, they discovered that light speed's not the absolute speed now. They've got particles that have gone faster. So, in a sense, if you've got a craft that's able to create a field and you can apply a big enough engine on the thing, it's going to accelerate really, really fast. But what he's saying, though, is that you don't actually need motors. You just have to control the field, and the energy, the vortex around it, will control, basically sucking it along like a stream. So he's got other ideas. So I reckon, if we go back to that diagram I drew initially, this is where we got different shaped craft. Now, this one here, the triangle craft, it's obviously generating a field by the middle part of the craft. It's got some sort of spinning happening in the middle of the craft here, and it's got engines on the corners that make so basically it's like a flying platform, but it's less weight because it's creating a field, but it's not the ideal shape, obviously. but it's got engines to push it along. And these other ones, the cylinder, the sphere, and the dome-shaped ones are possibly alien technology where they're using the field entirely around the objects. Obviously, the perfect shape's going to be a sphere because you can have a field just like a Tesla core that goes all around it. So you can move it any direction you like. Same with the flying saucer. The half dome one here is like a half a sphere. So basically, what was it? Bob Lazar said there was 3 pods underneath a typical saucer. So he would have, I'll simply draw it on. He had like 3 pods that come down. Is it going to go? I tell you, it's gone so slow. It's terrible. When it's slow, you can't draw very well. So even that's terrible. So he had 3 pods like that. And he was saying that they were ejecting gravitational waves out, which is totally wrong against what Tesla was saying. But in a sense, I guess if you could see that it was creating a field, and by moving these objects, 3 objects around underneath, you could make it hover or change the angle of this one upwards, would push it along to the right, and so for this one. So maybe Bob Lazar's not a fraud, but maybe he was fed some incorrect information. And it sort of all sort of fits to make sense now. So if you have a look at these other diagrams again, so this is our conventional thinking of space-time and how it bends space, and gravity is caused by the curvature of space. And this is the idea of Tesla that he said he found was a 4th dimensional layer of energy where atoms are always absorbing energy. And if you can affect one side of a mass from absorbing the radiant energy, so it only absorbs it from the top, say, then the gravity between the bottom of that craft and the gravity of the pull of the planet Earth doesn't exist anymore. So it's just hover there like a helium balloon. Now, how to do that, we don't know. Townsend Brown was trying to figure it out with the high voltage himself. And we know there's 40 trunks of Tesla that was taken probably by the FBI. So it kind of fits that maybe they got hold of his information and built these triangle flying platforms, as Tesla was talking about the flying platforms, using his wireless power. It's possibly they even figured out how to do wireless power, and these craft flying around using Tesla's research, and as absorbing the radiant energy that powers the field, which blocks the radiant energy underneath the craft. So you're using all parts of the idea of it all. Now, a sphere, as you know, if you put a ball in water, it's going to float. So you can imagine if you could modify the field underneath it, it's also going to float in the atmosphere. And it could be hundreds of tons in weight, and it wouldn't matter. Cylinder, again, is one of those shapes where it's circular, where the field can actually go around it. But the end points, are not going to be flat. They're going to be more what we drew here with the cigar shape. Where is it? Which is what Tesla's idea was. You get like a cigar shape on the side where it's sort of not flat. So the energy, again, can flow around it, the field, to block the radiant energy. So really need to focus on that side of the research. People need to go back to the drawing board, pretty much. So I think I've probably covered most of it, actually, as best I can. Now you just have to get your own head around it all. What's going on here? Is it still playing all right? Looks like it is. So anybody out there? Anyone want to ask questions? Have their input? Pretty sure I've forgotten something. Probably just going to talk more about the atom structure again as well. So maybe I'll cover that bit. I wonder if I can find that. So here's a ghost rocket picture here. Several actually photographs. A lot of people said they thought they were meteorites. But here's one of the patent drawings from Schauberger. And you can see he's got it spinning around and it creates a field, a vortex field, which can suck it along pretty much, suck it along through the atmosphere. And that's why probably a lot of them crash, because they're not exactly hovering, they're always constantly moving. And you might remember I did an episode also on a ghost rocket sighting back in 1952, I think it was, or was it 1948? 52 seems to ring a bell. After Roswell, anyway, was sighted by two pilots in a DC plane. They didn't fly too high back then, so they said it was parallel to them. It had windows. It was almost like a tourist ship that was flying past with Japanese snapping pictures out the window, sort of idea. But yeah, they're all the same idea as difference in energy. And if you can get the field around a craft, you can control its movement as well as make it hover. So I did one here. Here it is. 1948. It was 1948. Two pilot sightings, and as you can see, they drew a picture of it. This is also another good one to watch. I'm not sure why I got 4 downvotes for it. Probably security 10 fans, probably. But I'll paste that one there. Have a watch of that story. But I think they actually saw maybe one of these experimental craft that someone took over Viktor's work and perfected the ghost rocket. So pilot silent. So skim that one. It's quite an interesting case, I thought. Is it going to give it to us? It's just very slow. So they were flying one of these old planes in a stormy night, I think, or storm cloud, and they saw what looks like something from, was it Flash Gordon, one of these cigar type UFOs, which is very similar to what Tesla was talking about. I don't know even if it had a rocket engine at the end. I think that might be artistic license there. But it had a row of windows and it was parallel to the craft, they said. And they drew pictures. Here you go. Did they say it had the exhaust? So that could be the Viktor Schauberger vortex idea. That it would have created some sort of mist or something behind the craft. Orange flame, they reckon. And people said they've just seen a meteorite going past the plane. I think they would know the difference between a meteorite and a craft with windows, surely, you know. And here's another drawing by the other guy. Definitely cigar shaped and very much like a ghost rocket. They call it the Devil Ship. So I looked at how high the plane was flying and whether you could get a meteorite to even fly parallel at that distance in the sky. So that's what they had, a DC-3, because they only fly at a certain altitude. But they're talking about mile-high buildings, especially in Saudi Arabia. They're building one. There's a movie at the moment called Skyscraper, which looks very similar to this building here that I got. It's not a bad movie if you've not seen it. It's got the typical man that can survive millions of bullets and smash into side of buildings and not fall down and stuff, but it's a bit, you know, typical Hollywood overboard stuff. So here's an example of how high the plane was flying in the sky. And this is a thing that drops military jeeps. So it was flying this high when this craft was flying parallel to them. I don't think it was a comet or meteorite that they were seeing. I think they saw a real craft of some sort. Anyway, have a look at that. So I'm not just a debunker. I actually believe some of the sightings. When you start applying all the science and facts to it. So that was last year. I did that episode. Another interesting one, which is on a side note here, is this one about strange deaths and ufology. It's amazing how many people in the UFO field die of rare and strange cancers as well as suicide. So if you've not watched that one, have a watch of that one. It's quite interesting when you put all the things together into one episode. Maybe we shouldn't be studying UFOs because it's a high risk area that Men in Black or NSA is going to wipe us out so we don't spill the beans on UFOs. I'll probably have to wrap up soon because we've got to take the dog out for a walk. There he is there. This is my dog here. Where's he go? That's Charlie. Well, I don't think I can draw any more diagrams. So the dog is sleeping under a quilt here. That's how he sleeps at night in the basket. So it's cold winter. You can't see him. He's just got his nose sticking out. And I wake him up. Oh, what's happened? Here he is, popping out of bed. Doing a stretch. So he'll be waiting to go for a walk now. So there's another one there at the end I had of him catching a ball at the park. Yeah, looks like it's come to someone else's silly video. Why does it do that? There must be a way to stop that autoplay. And there's also one where he opens up the sliding door. He's figured out how to open up sliding doors. This one here. He's quite a clever dog. He's a half Kelpie, half Collie. He survived the earthquake. He had all these things falling down around him, and he managed to get out the house without it killing him. And he was only like a 2-month-old puppy at the time. So here's our sliding doors. And what I had to do is I had to rig up a rubber band auto shutter on the door so he can open it up, but it self-closes. And I think he might be in the room at the moment. I know, here he is. So I'm telling him to go and get the ball that's in the other room at the moment. And you'll see him open the door, bang, goes in, grabs the ball. He's a real funny dog. He's too clever for his own good. And then I tell him to bring it back in, and you can see him on the other side there. And he's trying to figure out how to open it with the ball in his mouth. No, he can't quite see it, but he does eventually do it. He figures it out. So this, when animals become self-aware, you don't eat them. Chinese eat dogs. I find that disgusting, and they eat cats as well. But you can hold him up to a mirror, and he knows he's a dog, and he knows it's him in the mirror. He's quite intelligent. There you go. Opened it up, but he's dropped the ball to have to do it. So he's dropped what we call the sock ball, and because it's made out of socks for kicking around the house. And YouTube's not playing nice. So I tell him to open the door and quickly grab it before it shuts. So he opens it up. There you go. Grabs it, pulls it through, and he's so pleased with himself. So yeah, he figured it out in the end. He understands English pretty good. Anyway. Should have made it a bit longer so those ads at the end, well, the click things don't show it. So yeah, been going since what, 7:30, a couple of hours is it, talking about this UFO stuff. So no one wanted to come and say hello down the side. I thought I might have seen TRC and Jamal or what's his name, Rene. So I'll wrap it up there, I think, and maybe cover topic more. I've probably forgotten something though. But you can see here, even on these Tesla ones, they have the 3 blobs underneath. Because if you have a look at all the patents that I did, there's an episode called US Patents, and they're all these like UFOs that have jet engines and stuff. But none of them are using energy fields to lift. They're just using brute force. I think one even had like a nuclear reactor on it. So yeah, that's what here on these ones. People get confused between wireless power. Radiant energy transmission was nothing to do with wireless power in this aspect where it's using 2 coils. It's totally different. And I think people were mixing up the 2 ideas of Tesla. He also messed around with getting power from the atmosphere and also from the ground. So he was working on lots of different ideas. This one here with the UFO, with the balls underneath, that was Adamski, and it was found that when they zoomed in the picture that it had GM written on it, General Motors, on the parts, and they knew it straight away it was made from car parts, and it was actually a model, so it wasn't, like a Billy Meyer contactee. I still can't find that drawing. of Tesla. Maybe I have to call it rocket or something. But to get those missing trunks of his trunks actually had the notes and all the specifications and dimensions and mathematics involved to actually build what his patents talked about. And if you watch that documentary, some guy called Eddie Gray figures out the radiant energy that Tesla was messing around with and got it to run a whole bank of lights off a car battery, and it drove electric motor at the same time. So we've actually lost, and of course what happened is people said the guy was a fraud and the government cut away his prototype, and when they got it back, I think it was missing parts. I think his wife took off with it, and one of the prototypes anyway, and eventually found it, but it's missing the spark gap, which is the key part of the whole prototype, because no one knows how to build one of these that he figured out. That he figured it out from Tesla's block diagrams, and someone's probably got all those notes and trunks somewhere. And they talk about it on that show on History Channel. I think it is called The Tesla Files. So go and dig it up, find it on a stream somewhere, and start watching it. And also what I've pointed out here on mine. Anyway, for all those that are watching and not talking, thanks for coming by. And I think I'm just going to wind down now. And if there's anything else, I'll just create another live stream and talk about what I missed or whatever in future. So I'm just going to close off my end credits because I've been going a couple of hours more. And I'm feeling a bit tired. And I'll just kick off and say goodnight. And hope you enjoyed the episode. For you to append all the bits together properly. Do like and share it. And hopefully next time there'll be more people around us, and as they have their say on their own science. Yes.